Yeah, hope you can listen me now. Yeah, hope you can listen me now. Okay, today is module 4. We will start the module 4. Perfect. So today we will study the functions, tuples, dictionaries, exception, runtime error, and data processing. The functions, we have already discussed the functions. Functions are actually built-in functions and the user-defined functions. We will study how the functions are helpful to reduce the code, as well as how we can work within a team when the code is split into a different developers, programmers, and they can separately work on a function, different functions, and that module will become a part of your program. And this is the code. You will cover the following topics. Okay. Okay, sorry, there was some echo in the voice. I checked some computer setting. Okay, functions, tuples, dictionaries, exceptions, and data processing. Actually, these are the part of module 4. So in this module, we will cover the following topics: code structuring and concept of function, function invocation and returning a result from the function, name, scope, and variable shadowing. We have already uh, seen some of the local variables and global variable like such. There will be a concept, tuple and their purpose, constructing and using tuples, dictionaries and their purpose, constructing and using dictionaries. Then we will use the exceptions and try statement with the accept clause, and Python built-in exception, and code testing and debugging. So these are the modules, and we will cover this today. We started. Actually, why we need the functions? So you have come across functions many times. So far we have seen functions. If I say, if um, I say like I'm using a print, this is also a function. Input, this is also a function. Okay, if I use these are the built-in functions. If I use a sum and I have to define this is a user defined function. Okay, this is a user defined function. This will be the user defined function. Okay, so this is a user defined function. So these two are the built-in functions. There are a lot of built-in functions we will also see, and we can have user defined functions, and that user defined functions that are all depends upon the need, how the actually the need is of your basic application. That application actually define what kind of code you are required, and what kind of function will be useful for that. That will be the number of parameters, types, return types, like this. Okay, so here print, int, float, input, these are the functions which we have already used. Okay, so when there is a some code, there is a some code, suppose I am using code here. Okay, there is an application like ncr. Okay, this is math function n factorial over r factorial into n minus r factorial. You can see 1 2 3, I have to find 3 times factorial. Okay, I have to find 3 times factorial. So that's mean 3 times factorial I need 3 times. So that's mean I need 3 times calculate the factorial. So one thing is that I write here enter a number, I say n and read the value to n, then again enter a number and that number is assigned to r, then n and r, and q, suppose q is equal to n minus r. So I have to find the factorial n factorial, r factorial, q factorial. I have to write the code here. Suppose if I calculate the factorial in 5 lines, suppose 5 lines, so 5 multiplied by 3, I have write 15 lines here. The thing, the code, the program which I have to execute, I have to execute more than once. The best practice is that I have to use as a function. Okay, like this is your factorial program to ncr. I write here fun factorial. Okay, with the number x as a parameter and return some value. Okay, val, that's it. So here I read number n and r and q is equal to n minus r. I just call n factorial, suppose fact, and I pass the parameter n. So this value will be passed to this x, and it will be calculate factorial and return some value, and this will become. Okay, so we have studied here in this case study, we need a function. Okay, number 2, definitely that have a name and parameter, and that will be return some kind of value. Okay, so in this is a definition of definition. Okay, this is the definition of function. Okay, so in definition of function, we will provide the functions name, parameter, return type. Definitely we will also provide the body of function. Okay, so we define a function like I will continue my example, def and factorial n. Okay, my code, if there is a return type, suppose val, that's it. Okay, this one. So this is the definition of my function, definition, because I define this. Okay, so when I will write my code here, when I will go to my main body, main program, this is suppose my main program, I will call here suppose n is equal to input enter a number, okay, and n to then factorial n, okay. So this will be pass this, okay. This is the calling of function. This is calling of function, and this function is called, okay. Number one, that should be in built-in functions, suppose built-in functions, and that can be pre-built-in in your library. Suppose you are working in pandas, numpy, and that are already a part of your program. You can use its functions, okay. If you are using, there will be error, and you can include that libraries, okay. Simple. And this is already knows by the language, okay, like input float int blah 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 blah, okay. The third one is user defined. Third one, user defined. So user defined is actually, suppose if I say here is a text calculation, and suppose anyone like increment salary deduction, okay. So like this, okay. So this is the way we can define our functions. There will be function name, function parameter, function body, and return type. That can be and cannot be, depends upon the nature of functions. Then when we have to call, there should be a, we must know the name of function, and name of function, that signature must match with the function which we have already defined, okay. Then there is a parameter, we can call it argument parameter, okay. Suppose I have here sum, and sum has x y z, okay. When I will call sum 3 4, so parameter will be mismatched, definitely there will be some kind of a error, okay. And if there is a, suppose I am looking for the string or list type, even then there can be an error, okay. We can also define default values, okay. If suppose there is a country, then employee name, okay. And I have already defined country by default, suppose Sri Lanka. So if the country value I will not provide that, by default there will be Sri Lanka, okay. And employee name I have to provide, okay. So these can be also set, we can fix there, okay. Now we start this chapter, and I hope almost I have covered the concept of functions. Divided the code, a good attentive developer's code divided the code. Sometimes yes, this is another way, this is another concept, and very beautiful concept. We have to divide the code actually, okay. We have to divide the problem, okay. Suppose each task we have a different function, okay. Suppose tax salary calculation, salary deduction, increment, profit, etc. We have each for of them we have some kind of a function, okay. So when there is a problem, we instead of having thousands of line code, we go for line of code, we not need for, just we will go into the relevant function, and we will study this and find the appropriate in appropriate way error. That will be very good. Instead of a thousands of line we study, there is a problem in a tax calculation, salary increment, deduction, payroll, any kind of this some profit and loss statement, there is an error, we will go into the relevant function instead of reading throughout the program. Secondly, because you have a lot of employees, so the thing is that you have a lot of employees, okay. So you looking for some task to this and some task to this and some task to this, and later on you have to compile and execute a core application. Okay, so this is very expert in mathematics problem solving, this is expert in other and you can also divide in this way. This is another example we can break the code. So the piece of a code becomes a large and reading the understanding may cause a problem. Consider dividing the separate smaller problem and implement each of them as a separate function. Okay, so here you can see decomposition, team for the developer. Okay, and there is a built-in functions, pre-installed modules. We as I already tell you that if we have a numpy, okay, so there are, we have pre-installed library, any module. There are a lot of documentation. You go here, documentation, okay, reference, you can see np.array. Okay, a lot of functions are there, fundamentals, format lab, user, data type, lot of things are available there. So if you have a pre-installed module, definitely a lot of functions will be there, and directly from your code you have your own functions, place them inside the code, you can use them freely. My first function, let's see how it will be work. Very simple. If suppose enter a number here, I don't know to work there, I'll like to come here. Okay, so suppose I have a def and I say welcome. Okay, print, so enter value. Okay, and instead of this I just write welcome. Suppose I try this code. Okay, right click and shift F10, enter a value 2, enter a value 3, 4. Okay, so this welcome actually execute this one, enter a value. I also take space. So if there is an error, instead of changing each section, just I will change here the calling of my function will be changed. So it also have a colon, a space, 3, 4, 5. Okay, you can see this is my function, and this is a user defined function. Def for define, welcome is name, parenthesis the sign of a function, colon, and after that there is indenting and I can write. Okay, def, you need to define the word define is a significant here. This is the what simplest function definition look like. Def function name, so you have a function body, after that you have to function body. It always start with the keyword def for define. Okay, the next after def goes to the function name. I have already explained it. So you have just to put here def, then suppose welcome, I write welcome, parenthesis, colon, and here will be space, you will start from here, here will be your code. Okay, so it will shows that this is under this definition. Like message, that's a message, we start here, we start here. Okay, let I execute this code. What is this? Okay, we start here, enter the value. I don't call this, let it also make a call of this code. Okay, I clean this, now I execute it. We start here, we end here, enter the value. Okay, so at the end, if I it reduces the line of code. I can just call that code will be automatically executed. I write here 3 times, 4 times, 5 times. So just it will be execute as many time as I will call, just it will be execute. I no need to write the code again and again. If intra value star, okay, so you can see. Next, we have already discussed this definition, invocation, body. That's it. It will be invoke, go here, execute, then again back to the code. Here one thing I want to explain more further. Here, if there is a return type, if it will be return some value, suppose x is equal to suppose read data, read underscore file. Suppose here I have a f is a file type object, and that's mean it will not go to the next line. The data will be read and it will be assigned to this variable. Okay, this is my variable. Okay, so this is the thing important. When you have to assign the value, your control will be shift on the same line. If that is not returning the value, that not have to assign the value, it will go to like if I say here is welcome, it does not return any value, so no need to come here. It will be execute and move to the next line, next line, next line. But here it has to also return the value. If it will be return the value, so you can also assign to a variable and control will be shifted on the same line. Message, intra value, message instead of okay, it's also cool, no problem. Everyone has its own style. This is just for the explanation. Enter the value, message, okay, so 4 3 like this. Okay, next, key take away. A function is a block of code, just to summarize, a code that perform a specific task. When a function is called, invoked, you can use functions to make your code reusable, better organized, and more readable. Okay, the functions can have parameters, argument, and that can also have a return value. Okay, there are the at least 4 basic types of functions: built-in functions, pre-installed functions, user-defined functions, and lambda functions. And that will be the part of essential 2, Python essential 2. And def will be use a keyword to define your function. What happened to try to invoke the function? Okay, so what will be here? An exception throws. Let me check what is wrong here. Okay, let me check. I execute it. There is an error. Uh, before calling, we must define this. So we have to define this. Now if you execute it, there will be no error. Next, parameterized functions, we can also provide a parameter. Suppose you can check here. We have some parameter here. Suppose I have def sum x y, and then this will be parameter. When where there I will be invoke, I will say sum 3 and 4. 3 will be to x and 4 will be for the y. Okay, parameter exist only inside the functions. It may be they have the defined, and assigning the value to the parameter is done at the time of the function invocation. Okay, so parameter have live inside the functions, argument exists outside the function. So parameter will be inside the function where we will define the function, function name. After that we have to provide the parameter and argument. When we are calling, we will actually pass the argument, we will pass the parameters there. So here these are the parameters. I pass 3 and 4, and these are receiving variables. It will receive, and x will have a 3 and y will have a 4. I just execute. Oh, missing one required positional argument. So if I write here suppose 5, let me check 5. So it goes to number receive, internal number is 5. Okay. If we write def what and number, okay, so how we can invoke? Very simple. You have to just write the message, that is the message function, the first parameter and second parameter. Okay, if you have to write the string, you will use the quotes, and if you have to write the number, you will write number without quotes, like this one. Okay, positional parameter passing, my functions a b c and print a b c. One, two, three. Okay, so one is for a b c, and if we have this first name Leo, Jasquick, Clark, and so this is the first name and last name. And what about I go to the next example, it will be continue. If when I pass, I explicitly mention first name is James and last name is Bond, so it will goes. Okay, we can use the equal sign operator. That will be more explicitly mentioned that the first name actually I assign James and last name assign the Bond. Okay, you must not be use the non-existence parameter name. Suppose some parameter does not exist. Suppose I am using this one, it works perfect. Okay, it works perfect, but I say not I say okay, first name surname, that does not exist, so there will be an error. Okay, we can mix positional keyword argument def abc, print a b c, and sum of these. So a b c, and here will be print some values like 1 2 3 and equal to 6. We can use a default value here. First name last name is equal to Smith, so this is the default value. I fix this one. If I just provide this one, and you can see by default Smith is there. If I will write nothing, then first letter first is compulsory. Okay, so that's why it is a mistake. Second one, if you will provide, it's okay, that will be override. If you will not provide, that has a default value. Return function can return some value. Suppose we have in the previous example at the beginning, I have already discussed with you. I have a 5 factorial. So if there's a 5 factorial, 5 4 3 2 2 1, it will return some value. So whenever there is suppose some max, min, average, standard deviation, there is a factorial, sine, cos, tan, sine hyperbolic, cos hyperbolic, tangent, cosecant, like blah blah blah. We provide some value here as a parameter, suppose 90 degree. It will return some results. So we learn how we can pass the value. No, if this function calculates some results, how we can get that. Okay, so this is the thing we will use. Keyword return we will use. Okay, return expression, boring function, return 1 2 3. Okay, we use this. Yeah, boring function has return result 1 2 3. And if I enter some value here x and I multiply by x, okay, and I also pass this value here, suppose 2. So 2 will be go here, 2 will be multiply, and let me check what will be the result. Okay, so I also pass the value, it also multiply some, perform some function and return the result. Okay, no, these are the further explanation. A lot of case studies are there. None. Print none plus 2 must not be part in my expression. So we check what is the none. Okay, none is a keyword. Okay, let I copy this and I execute this code here. Sorry, you don't carry the value. Okay, so none, if value is none. Okay, so none is not a numeric value, that will be in like in SQL. I just remember and want to share with you. In SQL, Oracle SQL, we have an idea of that null. We say where commission underscore PCT is null or is not null. So yet to be unknown, that was not if we have a 3000 4000, we can say where commission underscore PCT is equal to 3000, where salary is equal to 4000. These are numeric value. This is a something special, null yet to be unknown. So here we have a none, and for none we will use is. Okay, is none, where value is none, definitely values is none, so that's why it will be print this one. Okay, a few words about none. So we can check it here. Strange function 2 and 1. If I call this, let me try this. Okay, and I will modify this also definitely, and we will have some experiment here. Okay, so you can see one is a true and one is a none. If I say else, return false. Okay, so now you see, if I say 2 is divided by 2, remainder is 0, so that is true. And if I go for 1, there is nothing, so it return none. But if I put the else bidirectional, what will be the behavior? Let me check. Yes, true, false. Okay, and if it's not there, that will return the none. List and functions. We have a list here. Define list underscore sum, and sum's value is 0. So this is the function. Okay, so element in first, it will be take a value, and it will be sum. After the loop, it will return this sum. Okay, let me call this. It takes 5 4 3 and return the sum. Okay, so this is list of values. We can pass the list of value, and in loop we read one by one element 5 4 3 and sum up in a single variable. Okay, and then we print it. Effects and result, list and functions continue. So this is a 5 4 4 3 2 1 0. You can see here, this is a 5 is a list element. Okay, when it goes here, n will receive a 5 0 to 5, but 0 index is fixed. It will start from 4, then 0 is fixed, 4 3 2. Let me execute it. You can see 0 is fixed there. Okay, so it will start from 0 to 5. First value is 0, then 0 is a fixed value, then again next is 1. It will take I'll show you here 0. It will show the 0, but this will move to the next. Okay, because again on 0 index I have 1, so it will become this, then 2 1 0, then 3 2 1 0, then 4 3 2 1 0, like this. So because this is 0 index, 1 2 3 and 4, like this. So on 0 index I have fixed it, and then the value will be moved, and each time element on the 0 index will be changed. This is a estimate level of difficulty is easy. Students can have some practice with these activities. You can return a value using a return statement. Okay, like def wish return wish is equal to w, so its value will be returned to w, and we can print w. Instead of this, we can also directly wishes in the print statement, and we can call it like instead of this, I copy this and put it here, and this is like okay. Functions and scopes. Here x is 123. I don't pass any value, and I want to print here. Let we have, and there is an error, name error, x is not defined. So when we have defined some function inside the variable inside the function, that is its local variables. Okay, that cannot be globally accessed. You can see here this, if I check this this one, say this one, so this is a local variable. It destroy here, it cannot access outside. This is the global, like this, its variable can access everywhere. So when I try to cover it, that will show the error, and that will say okay, where is x. Okay, so or I use like a global keyword x, then I can access anywhere else. This is in first case, this is a local variable only that can be accessed only within the function. Let's see how the behavior is. Next is, so if I come here, var, no, you can see var is declared here and it can access here. So if we are outside the function, we declare a variable that can be accessed everywhere. If I use the global, so global means it is extend global, extend a variable scope in a which way include functions bodies. So we can use the global. So that will become the global scope. Var is equal to 1. So when it will become here, it will start, definitely execution will be from this there here. Var is equal to 1, my function var. Okay, so var will be 1 and n value is 1. I got 1 plus 1 is equal to 2, so n value is 2. I have 2. Let me execute. Okay, I got 1, I have 2, and after that print var. Okay, so var's value is 1. Okay, so var value is 1. That does not affect here. Okay, because we never assign the value to var. We not assign in this case. You see, we have assigned this one. So I never change, override the value of var. So var value is even after that above function is 1. So when I say print var, so that is even 1. So if I say 10, that's it. Some notes. This is a program, a function for BMI calculation. This is it about slash. So backslash symbol is used if you are using the Python code and end with the line. It will be tell Python to continue the line of the code into the next line. So that's why we use this. Okay. Else we can even go here and like this instead of that. These are some simple functions. Continue. Suppose triangle a plus b plus c. Just mathematics implementation in functions. This is for the Pythagoras theorem. C square is equal to a square plus b square, and c is equal to a square plus b square whole under root. Implementation and define a function. This is a hero formula. 3 sides of a triangle divided by 2, and s is equal to s minus a b c and under root. That will give you the area. Okay, we can also use this, just pass the parameter and we can have some return value. And for this it's okay, 3 lines we can read the value. This is a simple function for factorial. Define a function factorial. If it's less than 0, it will return none, and less than 2. Less than 2 means 1. 1's factorial is a 1, and product is equal to 1. We will have a range from 2 to n plus 1, and it will, because it will always go to n minus 1. That's why it has to n plus 1. It will be multiplied, and product will be assigned to product and return the product. Okay. So then we call it 1 to 6. It will give to 1 to 6 time. It will call this function, and it will give the 5 numbers of factorial. This is a Fibonacci series. Another example of a function. Next is we have sequence types and mutability. We have mutable and immutable. Like mutable objects that states can be modified. That state can be modified. So like list, dictionary, and sets, and immutable like integer, float, string, and tuples. So tuple prefer to use the parentheses, whereas the list like to set brackets. Okay. So first and clearest distinguish between list and tuple is the syntax which we have. So tuple we will use the parentheses, and in set we will use the square bracket. Okay. This is a tuple 1, tuple 2, tuple 1, tuple 2. When we print, it will be print like this. How to create the tuple? Empty tuple, just you have to parentheses, it is empty. You can have assign the value like this, or you can use without parentheses. Let me run it. So it will be write the 0 index, then it will be -1 from the right side, then it will be 1, and from 1 to because I don't have the upper limit, it will be print all, and then from -2 there is no -2, and it will give the from -2 this from first two elements to next it will be print. Okay. And this is in loop we have to populate my underscore tuple. We can use how to use the tuple continue. We can have a tuple to do length function accept the tuple and return the number of elements. We will see here, you can see length t2. Okay. So let me execute it. Definitely print will be start length t2 is here, t2 my tuple multiply by 3. Okay. This is 3 by 3, it is there are 9 elements. Then print t1, it will print t1 my tuple plus 1000, and this there is 1 10 and 100. So that's mean last sign has concatenate, that has to join more value. Okay. t1 this will be print, and t2 it will be printed the this one value 3 times because we have multiplied this, and print -t not in my tuple. So 10 is in my tuple, yes, it's true, and 10 -10 is not in my tuple, that is also true. So it will be return the true or false, in or not in. You can see here multiply will be to can multiply like this. Okay. Operator will be join the tuples, so that here that join and that multiply. Got it? Next is what is a dictionary? Actually the dictionary is very simple. Dictionary is like if I say in example we have a key and value, so like this is a key and value, like JSON is key and value, this is a key and value, key cat, and its value is a chat, comma, so this will be separate, dog and chain, and horse is shovel, boss for 555 and so this is a 22565785431 and it's empty. Let me print this dictionary and see what is the behavior of this. Next, it just print these values. How to use dictionary? If I say dictionary cat, and what it will be print, I will go here and just we check this. You can see I say cat and it will its value, and when I say Susie, it will be print its value, Susie, this one. Dictionary the keys, and key, this is a variable in dictionaries dot key. Dictionary, this is my dictionary dot keys. Okay. Key and dictionary key, it will print the keys only. You can see key, cat, dog, and horse. Okay. So if I take it, let me have some analysis. If I don't print this, what will be happen? Let me try. That's good. So it will be print this key. Okay. And Control Z, and if I just have to this one, Okay, next, items and values. You can see here dictionary, English, French in dictionary in items, and English. Okay, so let I execute this. These are just variables. The English, French, these are just a variable. In dictionary.items, it will return some value, and we are just executing this. So dictionary.items, when I say English, it will give the key, and whereas French, it will give the value. So later on, we can print it. We can how to use the dictionary modifier and adding the values. So here, adding a value. We go here, but before that I will first print this one. You can see cat, dog, and horse. Cat, dog, but here I change the cat value. Tuple and actions can also work together. So create an empty dictionary for the input of data. We have a empty dictionary. So then as use as the key while as associated scores and stores in a tuple. Okay, enter the infinite loop. Okay, so it is a infinite, always true, and enter the student name. If this is a null, that will be break, else it will get the value and score of students. And then after that, if name in school, then it will be add some score, else it will add school underscore scores. Okay, it will assign. Okay, sum and assign. For name sorters school underscore class dot keys, that we execute, that will be shows the exact behavior of this program. And there is a suppose Alan. Okay, so it will be have a students scores. Suppose student score is 4, and there is Andy. There is Andy and its score, and after that when I don't put the name, you can see here it's not, it will be break. So it will break, and what it will be do, it will be run this loop, and it will be count the student name, and it will give its average. Okay, so for each it will give the average, because we have a Bob, Andy, first Bob, Andy, Bob, Andy, so it will go the relevant, so it will give the average. Okay. So we use dictionary and list together. These are some notes and some examples. Error, errors in data, runtime errors are known as exception. How we can deal with these exceptions? So like this, when the data is not what it should be, like we go there. Okay, divided by suppose I have 0 and press enter. So there is a value 0 division error. Okay, so this is exception. Exception is a runtime error. So we have to make a try catch. We have to put into the try catch. So try and catch will be, so if we execute this, enter a value 0, so it will be not. So they, when we feel that there will be an error, we will put into the try. Okay, and after that exception, if there is any exception, the except pod will be executed. Except there is a predefined exceptions. You can go except if this, except this, except this, except, and we can have a specific and more accurate message for that. Okay, so we can use try with the multiple except. Like in Java, we have a try catch block. We do that. There are already predefined exceptions. Some useful exceptions: zero divider error, value error, type error, syntax error, attribute errors, and there is some code and you can test it. So here is a value. We will read if it is greater than 0, above 0, else less 0, below 0, else it is 0. So this is the testing and testers, bug versus debug. A basic measure of developers can use against bug is unsurprisingly a bug debugger, while the process during the bug are removed from the code is called debugging. Okay, so the bug is the unsurprisingly. Print debugging, interactive debugging. We can also on the debugging. Some useful tips. Try to tell someone, for example your friend or co-worker, your code is expected, you can escalate your senior. Try to isolate the problem. If that is a part of a problem, you isolate and you solve that. Instead of a whole program where there you think that there is a problem, you can make a separate function, you can execute, and there is a problem, you just focus on that. Analyze the all changes you have introduced to your code. If there sometimes code is looking very good and it's working, you make some change there that becomes a bug error, like, so you should focus on that. Take a break. Yes, that I love it. When there is a problem, just have a mug of tea, and after that you start. Most probably you are focusing on the error, you are in try that but with the same brain, you are actually creating the problem, you cannot resolve the problem. So take a break, go outside, and have a mug of tea, and then that will be definitely work. You will surprise how often it works, and definitely I always surprise. And be optimistic, you will find the bug eventually. We promise for you this. Yeah, that's a good approach. Unit testing or high level coding. These are some keyway exceptions. Print. You go for this. That will be show you a EOL, end of line, while scanning the value. So exception will be there. Definitely there will be bugs, everything. But as long as you will work with the code, everything will be fine. And that is the end of the module 4. The most important thing is a function. Functions are very powerful, and as long as you are very good, first thing you try to use your built-in functions, the functions with the specific libraries, and if you are good enough, you can write your own functions for the problem solving. And there is a function types with the parameter with the return type none, and then we also find the scope of a variable global and some local variables which are inside the function. Then we have some new data aggregates, tuple. Before that we have also studied the list, tuples, dictionaries, and their role in data processing, and concept of exception, that is a runtime error, that is known as exception. So this is the first section of Python.